Alright, chapter shield metal arc welding and wear facing. Shield metal arc welding process. Shield metal arcing processing referred to metal arc welding, stick welding, extensively used with welding ferrous, non-ferrous metals. Many applications produce vast assortment of metal products. Shield metal arc welding is found. Shield building industry and the construction industry, fabricating girders, beams, columns, bodies, easy use the portable shield, the metal arc welding, universally use the repair and service equipment, machinery, and host for the other items. Manual shield metal arc welding. Arc welding provides the ability to join two metals, melting them and generated between the coated metal electrode base metal with the temperature developed. The arc can reach as high as 10,000 degrees. Arc engine provided with the power source generates either the direct alternate current, but the electrodes current and carrying produce the gas through the shield of the arc through the atmosphere as supplier filler metal developed and weld shape. Arc welding equipment. Wide variety of welding equipment is available. There are many differences between the make of the model of the equipment produced by the manufacturer. However, all the type of the arc welding equipment are similar to the basic function produced the higher amp or low voltage electrical power required for the welding argument. In discussion, we are primarily concerned with the typical items of the arc welding equipment rather than specific types of the specific information about the equipment. Equipment battalion duty station has been available to consult with the manufacturer instruction manual. For additional information, safety instruction have the leading of the welding petty officer to explain the operation to the basic typical shield metal arc welding outfits include the weld machine, cable, electrode holder, stingers, electrode, steelworker. Also requires a number of accessories that include a combination chip can with a wire brush, welding table for shop wire, C-clamp protector for peel of the weld. Before we discuss the different type of the welding machines, you must first have the basic knowledge of the electrical terms used in welding. Electrical terms, many terms associated with arc welding. The following basic terms are equipment. Especially important. Alternating current is an electrical current that has an alternating negative and positive value. The first half cycle of the current is for one direction, then reverses itself for the next half cycle. One complete cycle in the current spends 50% of the time flowing one way and the 50% flowing the other way. The rate of the change direction with the frequency is indicated by cycles per second in the United States. If the alternating current is at 60 cycles per second. Amperage sometimes comes and refers to the amount of current that flows through a circuit measured by the amp meter. Conductor contains any of the material that allows passive electrical current. Current is the movement of the flow of the electrical charge through the conductor. Direct current is an electrical current that flows in one direction only. Electrical circuit electrical current is the path taken with electrical current through the conductor of one terminal and source for the load of the returning other terminal of the source. Polarity, direction of the flow of the current of the circuit, and the circuit current flows in one direction only. In a DC welded, polarity becomes an important factor of the welding operation. Resistance is the opposition of the conductor flow current. Resistance causes electrical energy to be changed into heat. Or shows a 300 amp AC/DC portable welding machine. Figure 17 shows an arc welding transformer, and that shows the amper scale adjusting crank, lower range temperature work, temp lead, high range temp, off on switch. A volt force required to make the current flow in the electrical circuit. It can be compared to pressure and hydraulic system. Volts are administered. They have voltmeter power sources. Power source for the arc welding is called the welding machine of the welder. Three basic welding machines are present: even the motor, generator, transformer, and rectifiers. Motor and welding machines are the type of welding machines that are powered electrical, gasoline, diesel motors. Diesel gasoline motors are ideally due to the areas where electrical is not portable. Portable gas diesel welding machines are not part of the equipment along with the naval mobile construction battalions. Are part of the equipment of the Naval Mobile Construction Battalion. The machines use the have the door capable of generating, altering the direct current. On the new machines, when you're welding in the direct current mode, the polarity can be changed by turning a switch. Some of the older machines require the reversing cable connections. One of the advantages of the direct current welding generator, if you have the choice of welding with either straight reverse polarity welding machine, as shown in Figure 7.1, consists of the heavy-duty AC 300 amp generator powered by the diesel engine. The generator is capable of producing 3 kilowatts at 60 amp cycles AC power. Welding machines are made in 6 standardized ratings. The general purposes are listed as follows. Machines rated 100 to 200 amp, 30 volts, light shield metal arc welding. For an air gas arc welding, there are also general purpose job and shop work. Machines rated 200, 300, and 400 amps for 40 volts for general welding purposes for by machine or manual application. Machines rated 600 amps, 40 volts, are for submerged arc welding, carbon arc cutting. Alternating current transfer welding machine. Practically all alternating current AC arc welding machines in use are static transformer type, shown in Figure 7.2. These type of machines are smallest, least expensive, the lightest type of the welders made with industrial application for manual operation. For the machines 200, 300, 400 amp ratings, machines with 150 amp rating are used in light industrial garage shop welding. Transformers are usually equipped with the arc stabilizing capacitor. Current control is provided to end the several way by welding transformer manufacturer. One such is an adjustable reactor set by turning a crank until the appropriate setting is found. Another method is by plugging the electrode cable into the different sockets located on the front of the machine. One of the major advantages of the AC transfer of the freedom of the arc blow often occurs by when welding at the direct current machines. The arc blow causes the arc to wander while you're welding in the corners on heavy metal or use large coated electrodes. This shows the cable size selection guide with the distance from the welder, total length of electrode, ground cable divided by 2, current amps, 50 foot, 75, 100, 120, 150, 175, 200, 225, 250, 300, 300, 400 feet. From amperes, 100, 150, 1, 200, 250, 300, 350, 400, 450, 500, 550, and 600. Alright, 7.3 shows the combination AC-DC transformer, rectifier, arc welder, fine adjustment, current adjustment selector, AC-DC, straight polarity, DC, or reverse polarity on switch. Rectifier welding machines, rectifier welders, single-phase, three-phase transformer that has silicone rectifiers added to rectify change the output current with the alternating direct current. Both of these machines have the capability of producing either AC or direct or reverse current, polarity current. By flipping a switch, welder can select the current that best suits the job. Figure 7.3 show with the example of the combination AC-DC rectifier cable welding cables carry the current to and from the workpiece. One cable runs from the welding machine to the electrode holder. The other cable connects the workpiece to the welding machine. Cable connects the workpiece to the welding machine is called to the ground. The machine is turned on and operator touches the electrode to the work piece of the circuit is completed. The current begins to flow. The welding process commences. Welding cables must be flexible, durable, well insulated, large enough to carry the required current. One cable is specifically designed for the welding should be used. A high flexible cable must be used. Electrical holder connection. This is necessary for the operator can easily maneuver the electrical holder during the welding process. The ground cable need not to be so flexible because once it is connected, it does not move. Two factors determine the size of the welding cable: the amperage rating of the machine, the distance between the work and the machine. If the amperage, the distance, increase the cables size also must increase. C table so the one cable that is too small for the amperage, the distance between the machine and the work will overheat. On the other hand, large size cables are more difficult to handle, especially if they're working on a structure that requires a lot of movement around. The best size cable one meets the amperage demand, but is small enough to manipulate the ease. As a rule, the cable between the machine and the work should be as short as possible. One continuous length of the cable, the distance less than 35 feet. If you must remove more, one length of the cable joining the section. Insulated lock type enable connection joints in the cable should be at least 10 feet away from the operator. Your electrical holder, commonly called the stinger, clamping device holding electrically so securely into the position level. The cable attaches to the holder through the hollow insulated handle. The design electrical holder permits quick and easy electrical exchange of the two general types of electrical hards and insulated and non-insulated. Non-insulated holders are not recommended because they're subject to accidental short circuiting if bumped against the work and peering welding. For safety reasons, try to ensure that they're usually only stingers on the job site. Electrical holders remain different sides of the manufacturer have their own system of designation. Each holder is designed for use a specific range of electrical diameter welding current. You require a large holder with a welding machine have the 300 amp rating, then welding is a 1 amp charge machine. If the holder is too small, it will overheat ground clamp. The use of the ground clamp is essential for producing quality welds. Without a proper ground clamp, the circuit voltage fails to produce enough heat with a proper weld, therefore possibility to damage the welding machine cables. 3 basic methods of grounding a welding machine. You can fasten the ground cable to the workbench with a C-clamp or attach a spring-loaded clamp directly down to the workpiece. Bolt, tack the weld the end of the ground cable to the welding bench. The third way is to create permanent common ground. Cleaning equipment. Strong welds require good preparation process. Each of the surface area of the workpiece must be free of all foreign materials such as rust, paint, oil, all steel. Brush is an excellent cleaning tool that is an essential part of welding equipment. The initial cleaning weld bead has been deposited with the slag cover the most of the remove the additional beans that are added. The chipping hammer is specifically designed for the task. Chipping operation is followed with more brushing and the cycle is repeated until the slag has been removed. While the slag is not removed as a result of the porosity of the weld, weakening the welded joint. Cleaning can also be accomplished by use of the power tools, chemical agents, and items are used. Essentially, all safety precautions are followed. Safety equipment. Arc welding not only produces brilliant light, but almost ultraviolet infrared reds that are very dangerous to your eyes and skin. In Chapter 3, personal safety items, helmet, lens, gloves that's covered. It's important. Items needed to be covered here in the welding screens. Welders not only has to protect himself, but he also must take precautions to protect other people who may be working closer by. When working in a field, you must install the welding screen around your work area, and it can be an elaborate factory manufactured screen or as simple as one structured on-site heavy fire-resistant canvas. Warning, never look at welding arc without proper eye protection. Look at the arc with a naked eye could result in permanent eye damage or receive flash burns that should be treated medical personnel. Another area often overlooked is ventilation. Welding produces a lot of smoke fumes that can be injurious to the welder if they allow it to accumulate, especially true with welding into a tank or other enclosed area. Permanent welding boots should be equipped with the exhaust hole and fan system for the removal of the smoke and fumes. Equipment and operation and maintenance. Learning to arc weld requires you to possess many skills. Among these skills are ability to set up and operate and maintain your welding equipment. Welding area requirements of most factory environments. The work is brought into the weld with achieved the majority of the time. Opposite of the truth, we will be called with the field of the welding of the building of the earth move the equipment and weld drill pipe. Drilling pipe shift the short fuel lines pontoon causeway with the list and goes on. To accomplish these tasks, you may have to become familiar with the equipment. Be able to maintain it in the field. It must be impossible to give the detailed maintenance information here because of the many different types of equipment found in the field. Therefore, only highlights will be covered. Welding machine operation and maintenance. You become familiar with the welding machines that you will be assuming that the manufacturer. Literature check with your senior PD officer for the chief the items that you do not understand. Machine setups involve the selecting current type of the polarity. Current settings of the current selection depends on the size of the type of the electrode used, the position of the weld, and property of the base metal. Cable size connections are determined by the distance required to reach of the work or the size of the machine with the amperage needed for the weld. Operator maintenance depends on the type of the weld of the machine used. Transfer rectifiers require little maintenance compared to the engine-driven welding machine. The transformer of the weld require only to be kept dry with a minimal amount of cleaning. Internal maintenance should be only done by electricians due to the possibility of electrical shock. Engine-driven machines require daily maintenance of the motors and most places where it will be required to fill out and turn into a daily inspection form called the hard card before starting the engine. The form is listed with items such as oil level, water level, visible leaks, other things that affect the operation of the machine. Transportation department are the ones who usually handle these forms. After all above the items have been checked, you are now ready to start welding. Shield metal arc welding. Before you start welding, ensure that you have all the required equipment and accessories listed below are some of the additional welding rules that should be followed. Clear the welding area, all debris and clutter. Do not use gloves or clothing that contains oil or grease. Check all the wiring cables are installed properly. Ensure that the machine is grounded and dried. Follow all the manufacturer directions. Operation of the welding machine. Have a hand on protective screen to protect others from welding areas of the flash burns. Always keep firefighting equipment on hand. Clean rust, scale, paint, dirt from joints if they are to be welded. Alright, 7/7 of the electrode covering gaseous shield that protects welded metals from the atmosphere. Should the extruded coating, gaseous shield, arc, steering base material, molten metal, electrode coating deposited as slag. Electrodes in general, all electrodes are classified in 5 main categories: mild steel, high carbon steel, special alloy steel, cast iron, non-ferrous. The widest range of arc welding done with electrodes with a mild steel groove electrode manufactured using specifically position many different types of metal that are specifically designed to use the AC DC welding machines. Some manufacturers' electrodes work identically on either AC or DC, while others are best suited for the flat position welding, and another type is primarily for vertical overhead welding. Some can be used in any position, and you can see that the electrode selection depends on many variables. The type of the electrodes. Electrodes are classified either bare or shield. The original bare electrodes were exactly the their name and implied with the bares today. They have light covering, but they even improvement and they're rarely used because of their limitation, the difficulty of the weld, to produce little brittle welds and have low strength adjustable with all the welding done on the shield electrodes. Shield electrode have a coating of several chemicals such as cellulose, titanium, sodium, low hydrogen, sodium, iron powder. Each of the chemicals and coatings serve a particular function of the weld process. In general, the main purpose of the introduce the easier arc starting, stabilize arcing, improve welding appearance and penetration, reduce spatter and protect. Molten metal from oxidation contamination surrounding the atmosphere. Figure 7 and 8 show the explanation AWS classifications. Fourth, with digit 1, cellulose, potassium, AC, reverse. Show the, alright, all mild steel, low alloy electrodes classified in 4 or 5 digit numbers prefixed with the E. E stands for electrode, first 2 digit, 3 digit, tensile strengths relieved as well. Third or fourth digit position of the welding, all position flat, horizontal, vertical, overhead, 1, horizontal and flat positions, only 2. And then show the fourth digit and the type of coating and welding current. As molten metal deposits with the welding process to attract the oxygen and nitrogen, since the arc stream takes place for the atmosphere, oxidation occurs while the metal passes through the electrode to the work. When this happens, the strength and ductility of the welder reduces while the resistance corrosion. The coating of the electrode prevents the oxidation taking place. The electrode melts. Heavy coating releases the inert gas around the molten metal with the exclusion of the atmosphere from the weld. Figure 7.7. The burning residue of the coating forms a slag over the deposit of metal, slows down from the cooling rate, produce a more ductile weld. Some coatings include a powered iron that is converted into steel by intense heat of the arc as it flows into the weld deposit. Electrode identification. Electrodes are often referred to the manufacturer trade name in American Welding Society. American Society forcing material that have the certain of the requirements of electrodes to ensure the degree of the uniform manufacturer electrode with the different manufacturer electrode that are within. Classification established for the AWS ACSM should have the same welding characteristics. See Figure 7 and 8. In this classification, each of the electrode is assigned with a specific symbol. E6010, 7010, and 8010 prefix identify the electrode for and this shows electric arc welding, first two digits of the symbol with this and maximum minimum allowable strength in the 1,000 pounds per square inch deposit of the welded metal. For instance, 60 series electrode have the minimal tensile strength of 60 pounds, 1,000 pounds per square inch, while 70,000 have 70,000 pounds per square inch. Third digit symbol indicates the joint position. Electrode is designed two numbers for either the purpose of 1, 2 for the number 1 design. Electrode that can be either the welding and either the position. Number 2 represents electrode bristle for welding in horizontal flat position only. The fourth digit of the symbol represents special characterized electrode, such as the welding quality of the current amount penetrate for the number of the range 0 to 8. So the welding position is dependent on the manufacturer characteristic of the coating, and third and fourth numbers are often identified together. Electrode selection. Several factors are critical to when you choose an electrode for welding. Welding position, in particular, significant. Table 7.2 show the recommended current type of the welding position for the most common electrodes. As a rule of thumb, you should never use an electrode with a diameter large for the thickness of the metal for the welding. Some operations prefer larger electrodes because they permit faster travel because of the take a lot of expense of the produced certified welds. Position type of the joint also a factor for determining the size of the electrode. For example, in a thick metal section with a narrow V with a small diameter electrode, use the end of the fun frosted weld. The root passes is done to ensure full penetration at the root of the weld. Successful passes are then made in large extruded vertical overhead welding and 3/16 of an inch largest diameter electrode that you should use regardless of the plate thickness. Large electrodes make it too difficult to control the deposit of metal. For economy, you should always use the largest electrode that is practical for the works and takes the 1/2 of the time to deposit the equal quantity of the welded metal. 1/4 of an inch in electrode, the 3/16 of an inch in electrode, same time large side of the not only allow you the higher currents, but also require fewer stops to change the electrodes. Deposit rate, joint preparation also important. The selection of the electrode for the welding metal seal to classify the fast freeze, fill, freeze, fast fill. Fast freeze, the electrodes produce the snap to tape penetration arc, fast freezing deposit. And they are commonly called reverse polarity electrodes, even though some of them can use an AC. These electrodes have the little slag produce flat beads. They are widely used in all positions, whether in both fabrication or repair. Fill freeze electrodes have them moderately free at 4 forceful arc deposit rate because they are fast freeze with the fast fill electrode. They commonly call the straight polarity electrode, even though they may be used in an arc. And these electrodes have the complete slag covered with the well deposit, distinct even the ripples of the general purpose electrode with the production shop or by the use of repair work. They can be used in all positions with the fast freeze. Electrodes are still preferred vertical overhead welding among fast fill electrodes. Or heavily coated iron powder electrodes off the arc and fast deposit rate. The electrodes have a heavy slag with a produced exceptional smooth welding deposit. They are generally used for production welding where they work within position for flat welding. Another group of the weld electrodes, the low hydrogen type, develops with the welding high sulfur, high carbon steel. These electrodes produce X-rays. Quality deposit with reducing the absorption of the hydrogen that cover the porosity and crack under the weld bead. Weld stainless steel required for the electrode containing chromium and nickel. All stainless steels have the low thermal conductivity that causes the electrode over the heating and improper arc action. The high currents are used in base metal with the cause of large temperature of the differential between the weld and the rest of the work, which warps the plate with the basic groove of the weld. Welding stainless steel will avoid high currents with high heat with another reason for the keeping the weld cool to avoid carbon corrosion. There are also many special purpose electrodes for everything welding: copper alloys, aluminum and cast iron, magnesium, nickel alloys, and magnesium steel composition electrode designed much of the base metal, but the basic rule of selecting electrodes is to pick one of the similar in composition to the base metal. electrode storage is expensive, therefore loss of the deterioration through improper handling storage can become very costly. Also, always store them in the dry place at room temperature, 50% of the maximum relative to the humidity and moisture caused by the coating of the electrode with the disintegrate, fall off. Low hydrogen rods are especially sensitive to moisture. After removing these are out of the original packaging, you should store them into the storage space maintained with a temperature between 250 to 450 degrees Fahrenheit. Portable stationary drying ovens to use the store of the preserve of the electrode with the specified temperature for the care that should be taken with handling electrodes because of the bumping, dropping them, and causing coatings to fall off, rendering the rods useless. Polarity. Early in this chapter, AC with the DC were briefly covered the welding machine. In the AC welding machine's polarity is not with a problem when you have the AC the DC welding machines. You can weld to either straight polarity, reverse polarity, polarity in the direction current flow in the circuit with the shown figure 7 high straight polarity. Electrode is negative with the workpiece, positive with the electrons flow with the electrodes of the workpiece. The reverse polarity electrode is positive in the workplace is negative. In the reverse polarity, electrode is positive and the workpiece is negative. Electrons flow from the workpiece to the electrode to help them remember the difference. Think of the straight polarity as the senator, of the reverse polarity as representative. Use only the first 3 letters each keyword. Senator stands for straight electrode. Reverse stands for reverse electrode, positive. Alright, 7 to 9 show the straight reverse polarity and electrical, show the electrode worker positive going to the arrow, the ground lead, a straight polarity, electrode is negative, reverse is positive. On some of the older machines, polarity is changed with a switching cable. One of the newer machine with the polarity can be changed by turning switch on with the machine. Polarity affects the amount of the heat going into the base metal by changing the polarity directly the amount of the heat where it is needed. When you use the straight polarity with the majority of the heat, the direction of the torque of the workpiece. When you reverse the polarity, heat is concentrated with the electrode. In some the situation is desirable to have more than heat on the workpiece because of the size. Need more heat to melt the base metal with the electrode. Therefore, when making large heavy deposits, you should use the straight polarity. On the other hand, overhead welding is necessary. Rapidly freeze filler metal so fast the gravity will not cause it to fall. The reverse polarity less heat with the concentrated workpiece. This allows the filler metal to cool faster, give it a greater holding power. Cast iron welding is another good example of the need to keep the workpiece cool for the reverse polarity permits with the deposit with an electrode to apply it rapidly while preventing overheating in the base metal. Generally, the straight polarity is with all mild steel with airly light coated electrodes. While these types of electrodes, majority of the heat is developed at positive side with the current of the workpiece. However, when heavy coated electrodes or the gases given off within the arc may alter the heat conditions. So the opposite is true for the greatest of the heat that is produced on the negative side of the electrode coatings. Affect with the heating condition with differently. One type of the heavy coating may provide the most desirable heat balance with the straight polarity, while another type of the coating on the same electrode may provide a more desirable heat balance with the reverse polarity. Reverse polarity is the welding of the non-ferrous metal, the type of aluminum, bronze, and metal with the nickel, and the reverse polarity with some of the type of electrode make the vertical and overhead welds. You can recognize proper polarity for a given electrode, sharp with the crackling sound of the arc, and the wrong polarity called for the arc to make with a hissing sound of the welding bead is difficult to control. One of the disadvantages of the direct current welding is an arc blow. Stated earlier, with the arc blow causes the arc to wander off while the arc welding in the corners of the heavy metal when used in large coatings of electrodes. Direct current flowing through the electrode workpiece with ground clamps generate the magnetic flow with around each of the units. The field can cause the arc to deviate from the intended path of the arc is usually the deflective of the torque of the backward along the line of travel that may cause the excessive spatter incomplete fusion. And also have the tension tendency to pull atmospheric gases into the arc and resulting in porosity. Arc blow can be corrected by one of the following methods: by changing the position of the ground clamp, by welding away with the ground clamp, or by changing the position of the workpiece. Alright, starting the arc twice. 2 basic methods of starting the arc are striking and brushing method to the end, figure 10, 7 to 10, and it shows the surface work of the arc gap and the arc established. Tapping method, either method are started by the short-circuiting welding current between the electrode work surface. The surge of the high of the current cause for the end of the surface of the electrode, small spot with the base metal spinning over the electrode to melt instantly. Striking and brushing method, the electrode was brought down to the work. Lateral motion similar to striking a match. As soon as the electrode touches the working for a surface, it must be raised to establish the arc. The arc length of the gap between the end of the electrode work should be equal to the diameter of the electrode with the proper arc length of the obtained. Produce a sharp of the crack sound. In tapping method, you hold the electrode in the vertical position surface of the work. The arc is started by the tapping and bouncing down the work surface and then raising it at a distance equal to the diameter of the electrode. While the proper length of the arc, the established sharp and crackling sound is heard. When the electrode is withdrawn too slowly with either starting method described above, the end it will stick freeze of the plate with the base metal with it is curved and usually free with the electrode with a quick side wave of the wrist motion of the snap the end of the electrode from the plate. If this is a method failed, immediately release the electrode with the holder, shut off the welding machine, usually a light blow with a chipping hammer to chisel tip of the free of the electrode from the base metal. Cause never remove your helmet and shield from your eyes as long as there's any possibility that the electrode could produce an arc. After you strike the arc, the end of the electrode metal with the flows in the molten created with the base metal with the compensate with the loss of the metal with the must of the length of the arc. Unless you keep the moving the electrode closer to the base metal with the length of the arc with the will increase the iron arc with it too long with half of the humming type of the sound. One of that is too short makes the popping noises. When the arc is fed down to the plate with along the surface of the constant rate of the bead of the metal with the deposit of the weld down to the surface of the base metal after striking the arc. Hold it for a short time in the starting point with the ensure the good fusion and create a deposition. Good arc of the welding depends upon control of the motion of the electrode along the surface. Motion electrode along the surface of the base of the metal. Setting of the current amount with the current during the welding operation depends primarily upon the diameter of the electrode. With the rule, higher current, the larger diameter of electrodes are better for the welding flat position than the vertical overhead position. Manufactured electrodes usually specify the current range at each side of the side of the electrode. The information normally found on the face of the electrode container. This is most recommended current settings that are on the approximate final current settings of adjustment needed to be made during the welding operation. For example, the recommended the current range from an electrode is 90 to 100 amps. Usual practice is set the controls midway between the two limits of 95 amps after starting the weld, making the final adjustment by increasing the current. When the current is too high with the electrode melts, the faster molten pull will excessively large, and irregular high currents also leave the groove in the base metal along with the both sides of the weld. This is called undercutting. An example is shown in figure 712. If you see when the current is too low, there's not enough heat to be melt the base metal with the molten pool will be too small with the result of the pore fusing the irregular shape the deposit of the piles of the up the shown figure 712 of view B. Piling up the molten metal is called the overlap of the molten metal from the electrode lays on the work of the without penetrating the base metal with the both undercutting and the overlapping result of the pore welds is shown in figure 713. Alright, when the electrode current polarity are correct, the good arc produces the sharp crackling sound. When any of these conditions are incorrect, the arc produces a steady hissing sound on the top of the steam escaping. And normal weld, too current low, too low, current too high, speed too fast, speed too slow, and arc too long. Poor weld undercut. In the bead, pore weld overlap, lengths arc and equal diameter electrode, short arc, long arc. Length of the arc is too long with the metal melts off of the electrode. Large globules of the arc may break frequently with the produced widespread or irregular deposit in position fusion between the base metal and the weld. Figure 712 view F. When the arc is too short, the fails to generate enough heat to melt the base metal properly coupled with the electrode, stick frequently to the base metal to produce the uneven deposit of the regular ripples. Recommended the length of the arc is equal to the diameter of the rear end of the electrode as shown in figure 714. Length of the arc depends upon the type of the electrode, the type of the welding being done. Therefore, the smaller diameter electrodes are short arc and necessary with the larger electrodes. Remember, the length of the arc should be equal to the diameter of the bare electrode itself. When welding is vertical overhead position, either position short arc is desirable because it gives better control of the molten metal that prevents atmospheric impurities from entering the weld. Here shows your work angle from horizontal, from vertical to travel angle, 50 to 30 degrees. Electrical angle to which the hole of the electrode greatly affects the shape of the weld. B, very important, fill with the deep of the groove of the welding electrode. The angle of the two position work angle, the travel angle, the work angle of the horizontal measure for the right angle, the direction of the weld. And travel angle is the angle of the direction of the welding may vary with 5 to 10 to 30 degrees depending on the welder choice of the condition of the work angle. Especially important with the multi-pass fillet welding. Normally, a special variance of the work angle does not affect the appearance of the quality of the weld. However, the undercuts are curved with the vertical section of the fillet weld. The angle of the arc should be lowered and the electrode directly moved toward the vertical section. Travel speed with the rate of which the electrode traveled along the weld. The seam of the maximum speed of the welding depends on the skill of the operator, position of the weld, the type of the electrode, with the required joint penetration. Normally, when with the travel speed with the too fast of the molten pool, cool if it's quickly locking impurities cause the weld to be narrow. With the pointed ripples as shown figure 7 to 12 view deep. On the other hand, travel speed is too slow with the metal deposit piles up successfully with the weld is high when the wide is shown in figure 7 to 12. View E, in most cases, the limiting factor for the highest speed with the produce the satisfactory surface appearance of the normal weld is shown in figure 7 to 12 view A. Breaking the arc. Most commonly used the method to break the arc is to hold the electrode stationary until the crater is filled, then slowly withdraw the electrode. This method reduces the possibility of crater cracks, re-establishing the arc. When it becomes necessary to re-establish the arc is long with the weld, with the required with more than one electrode of the crater must be first to be cleaned before striking the arc. Strike the tip of the new electrode after the forward and cool end of the crater and establish an arc. Move the arc backward over the crater and then move the forward again and continue with the tie with the weld. Procedure fills the crater and prevents porosity and slag. Inclusion. Peening. Peening is procedure involved with light hammering of the weld. As it cools, the procedure process aids the revealing built-up strength of preventing surface cracks into the joint area. However, peening should be done with care because excess hammering can work with hard and increase stress in the weld. The condition leads to weld embrittlement and early failure. Some welds are covered within specific codes of the prohibited peening, so they should check the welding specification before peening. Arc welding position, type of the weld joint with welded position, U of the manual shield, metal arc weld are very similar to the U of the oxygen gas weld with the natural, but the technique is somewhat different because of the equipment involved is different. Alright, square groove weld, reinforcement of the weld, a double bevel groove weld, single V groove weld, single U groove weld, reinforcement of the weld. Double V groove, double U groove, single J groove, single bevel groove weld, double J groove. Alright, flat position welding. Earlier we explained with the welding can be done with any position, but in the simpler when it is done with the flat position of the work is less tiring with the weld. Speed the path of the molten puddle is not likely to run. Better penetration can be achieved whenever possible. Try to position the work so you can weld with a flat position. Flat position of the face of the weld is approximately in a horizontal joint type. Butt joints are primary type of the joints used in flat position welding. However, the flat position welding can be used just about any type of the joint, providing you can rotate sections you're welding on. The appropriate position technique is useful in making butt joints flat position with or without the use of the back strip as described below. Butt joints without backing strip of the butt joints, use the two plates have the surface about the same planes over the forms of the butt welds shown in figure 7 and 17. Plates up to 1/8 of an inch thick can be welded in one path, no special edge preparation. Plates of 1/8 to 3/16 of the edge and thickness can be welded with no special edge preparation, but welding both sides of the joint. 1/8 of an inch minimum root opening, root weld, 1/8 of an inch root face, 60 degrees, 30 degrees, and they stacked them. This shows the single bevel, single 1/8 of an inch minimum root pass. And this shows manipulation. You can either do starts, aids, figures, car, whatever you want, really pretty much. Tack weld should be used to keep the plate of the line for the welding electrode motion, same as those used to make in the weld. B, the welding 1/4 inch plate heavier, you should use the proper edge of the U, the J, with the U, the V groove, whichever the most applicable. You single the double bevel grooves when in the specification and or plate thickness requires it. First B, deposit the shield of the space between the two plates. Weld the root of the joint. The speed of the layer of the weld metal must be thoroughly cleaned to remove all the slag and the dirt before the second layer of the metal is deposited. Alright, 720, undertaking butt joint weld, the undercut root weld, the undercut root of the weld, the undercut or root of the weld, making multiple blast welds shown in figure 7 and 18, second, third, fourth layers of the weld metal are made with the weaving motion of the electrode clean with each of the layer metal before laying additional beads. You may use the one of the weaving motion shown in figure 7 and 19, depending upon the type of the joint inside of the electrode. And they even weave the motion oscillate, move the electrode uniformly inside the slate, the hesitation end of each of the oscillation, including incline electrode 5 to 15 degrees directional weld is in the welding. When weaving motion is done properly, undercutting could occur with the joint as shown in figure 720. So if the welding speed also can cause undercutting, pore fusion at the edge of the weld bead. Butt joint to the backing strip, the welding 3/16 of an inch plate thicker to require the backing strip to ensure the complete fusion of the welded root pass. To provide better control of the go of the arc, the weld of the metal will prepare the edge of the plate in the same manner as required with the welding without backing strips. for the backing strip and the welds. 727 shows the horizontal groove weld, 1 pass, 2 pass, 3 pass. Horizontal fillet weld, 4 plates 3/8 of an inch thick of the back strip that should be approximately 1/8 of an inch, 3/16 of an inch thicker. For more plates, 1.5 inch thick of the back strip should be 1.5 inch wide with 1/4 inch thick of the tack weld of the backing strip of the base for the joint. As shown in figure 721, back strip extracts from the cushioning for the root with a path of the complete joint with the welding additional layers of the metal. After you complete the joint of the back strip, it may be washed or cut off with a cutting torch specified with the place of the seal of the bead along with the root with the joint. Bear in mind there are many times it will not always be possible for the backing strip, therefore the welder may just be able to run the root path with a good penetration without formation of icicles. Horizontal position welding will discover that impossible to weld all of the pieces of the flat position. All of the work must be done with a horizontal position. Horizontal position has 2 basic forms depending on whether you use weld with the groove weld or fillet weld with the groove weld. For the axis of the fillet welds for the horizontal plane face of the weld is vertical plane figure 722 and fillet weld with welding performed on the upper side of the relative horizontal surface against the approximately vertical plane figure 723. 724 shows horizontal welding angles, 5 to 10 degrees travel angle. Tack weld in the T-joint element place. Inexperienced welders usually find horizontal position arc welding difficult, at least for the heads of the developed a fair degree of the skill applying the proper technique. Primary difficulty is that the position you have a no shoulder of the previous deposited weld for the metal to hold the molten metal. Electrode movement, horizontal welded position electrodes over the points upwards of 5 to 10 degree angle in conjunction with a 20 degree travel angle. Use the narrow weaving motion, laying the bead. Waving motion distribute the heat evenly with reducing the tendency of the molten puddle to slag. You should use the shortest arc length possible when the force of the arc and undercut the plate with the top of the bead and lower with the electrode, alter a little to increase the upward angle. As you move in and out with the crater plate, pause slightly each time you return that keeps the crater small and the bead that has less tendency to slag. Joint type, horizontal position welding can be used most for the type of the joint with the most common types of the joint is either in T-joints, lap joints, and butt joints. T-joints make with the T-joints in the horizontal position 2 plates at right angle with each of the form of the inverted T with the edge of the vertical plate with a bead tacked weld within the surface of the horizontal plate is shown in figure 7.5. Fillet weld, either making the T-joint and short arc necessary to provide good fusion and F of the root and along with the edge of the weld, figure 726 view A, and hold the electrode at an arc angle of 45 degrees in 2 places over the figure 726 view B, and incline the approximate figure 15 degrees to the direction of the weld. When practical, weld light plates fillet weld 1 plate path with little no weaving electrode welding. Heavier plates may require 2 or more passes with the second pass layers made with a semicircular weaving motion. As shown in figure 727, to ensure the good fusion of preventing it undercutting of the issue, make the slider pause. At the end of each weave, the oscillation fillet weld is T joints over the 1/2 inch plate or heavier deposit string or beads in sequence shown in figure 728. Semicircular circuit, crescent wave, 2D layer, direction over the weld, 1 pass, weave motion, multi-pass fillet weld, 1, 2, 3, order making stringer beads, T-joint and heavy plate, tacking weld, lap joint, position electrode on a lap joint, chain intermittent, staggered intermittent, fill is shown in this figure 729, use the long T-joint. Fillet welds with each type of these of the joints for whether the high weld strength is not required for the high with the short. Welds are arranged and finished in joint and equal for the strength of the joint as a fillet weld along with the entire length of one side of the intermittent welds also have the advantage of the reduced warpage and distortion. Lap joints, when you make the lap joint 2 overlapping plates of tack weld in figure 730 with the fillet weld deposited along with the joint. Procedure for the making of fillet welds are similar to the making fillet welds in T-joints. You should hold the electrode in forms of the angle about 30 degrees from the vertical incline, 15 degrees of the direction welding. Position of the electrode relation to the plate is shown in figure 731. The waving motion is the same as over the T-joint except with the part of the edge of the top of the plate long enough to ensure good fusion with the undercut and lap to ensure enough lap joints and 1/2 inch plate heavier is made with the deposit in the sequence string or beads as shown in figure 731. And making lap joints on plates different thickness, you should hold the electrode so far that it forms an angle between 20 and 30 degrees from the vertical. careful not to overheat, undercut the thinner plate edge of the butt joints. Must be with the butt joints designed horizontal welding, bevel the plate position on the top of the plate with the non beveled on the bottom of the flat edge of the plate. Provide shelf for the molten metal so that it does not run over the joint, out of the joint. Often both edges are beveled in the form of a 60-degree included angle when the inside of the joint is used with the more skill required because you don't have to retain the shelf to hold the molten metal puddle. Number of the passes required for the joint depends on the diameter, electrode, the thickness of the metal. When multiple passes are required in Figure 734, place for the first spade deep into the root of the joint. Electrode holder should be inclined with about 5 degrees downward. Clean and remove all the slag before applying to each of the following beads. Second one bead should be placed with the electrode holder held with the 10 degrees upward. Third pass for the hold the electrode holder 10 and 15 degrees downward for the horizontal. Use a slight weaving motion and ensure that each of the bead penetrate with the base metal. Vertical position weld. In vertical weld is defined as a weld applied with the vertical surface of one with the incline with the 45 degrees to the left. 7 in Figure 735 of the erecting structures, such as building platoons, tanks, and pipelines requiring welding in this position. Welding on a vertical surface is much more difficult than welding in a flat horizontal position due to the force of gravity. Gravity pulls the molten metal down with the counteract with the force which should be used to pass free with the fill freeze electrodes. Vertical welding is done either in an upward or downward position. The terms use the direction of the welding are vertical upward, vertical down welding is suited for welding light gauge metal becomes penetration shell with the dimension of the possibility of the burning through the metal. Furthermore, vertical down welding is fast with very important production work. Current setting electrode movement. Vertical arc welding current setting should be less than when those use the same electrode in the flat position. Other difference is the current used for welding upward vertical plate is slightly higher than the current used the welding downward on the same plate. Alright, direction of the weld, vertical bead welding up, whipping up motion, 1/4 inch direction of weld, weave bead 1/2 inch wide. Vertical bead welding down, direction of the weld, 90 degrees, 15 degree, weave bead 1/2 inch wide, slightly semicircular weave. To produce good welds, you must maintain them proper angles between the electrode base metal and vertical upward. Show that you should hold the electrode at 90 degrees vertical, shown Figure 736. View A, when even necessary, oscillate with the electrode as shown Figure 736. View B, the vertical down welding incline outer end of the electrode downward about 15 degrees from the horizontal wall, keeping the arc pointing upward to deposited molten metal. Figure 736. View C, with the vertical down welding requires a weave bead, and you should oscillate with the electrode as shown Figure 736. View D. Alright, joint type. Vertical welding is used the most for the type of the joints. The type of the joints most often used is most of the RT joints and lap joints, butt joints. When making fillet welds, either the T lap joint vertical position, hold the electrode 90 degrees with the plate for no more than 15 degrees off of the horizontal proper motion metal control to keep the arc and should obtain with a good fusion penetration. T joint of the weld, T joints in vertical position start with the joint on the bottom of the weld upward. Hesitate direction upward, direction of welding. Showing the weaving motions, shows the direction of the welding, 90 degrees. Weaving motions, Alright, moving the electrode triangular weaving motion of the shown Figure 737 of the view A. Slight pause in the weave at the point that indicate the roof of the side wall for the penetration provides good fusion at the roof of the joint. When the weld metal overheats, you should quickly shift the electrode away from the crater without breaking the arc. As shown Figure 737 of view B with remains molten metal solidified without running downward. Return the electrode immediately to the crater of the weld in order to maintain the desired size of the weld. When more than one pass is necessary to make the T of the weld, either weave the motion shown in the Figure 737 of view C and D. Slight pause at the end of the weave will also ensure the fusion without undercutting the edge of the plate.